Welcome to myprojectbazaar.com. Our project title is An Efficient Hybrid Switched Network on Chip for Chip Multiprocessors. Abstract. Chip multiprocessors requires a low latency interconnect fabric network on chip to minimize processor stall time on instruction and data access that are serviced by the loss level cache. While packet switched mesh interconnects sacrifice performance of many core processors due to NOC induced delays, existing circuit switched interconnects do not offer low network delays as they cannot hide the time it takes to set up a circuit. To address these problems, this work introduced CMA, that is a hybrid circuit switched and packet switched mesh based interconnection network that offered slow LLC access delays at a small area cost. CIMA uses virtual cut-through VCT switching for short request packets and benefits from circuit switching for longer delay-sensitive response packets. While a request is being served by the LLC, CIMA attempts to set up a circuit for the corresponding response packet. By the time the request packet is served and the response gets ready, a circuit has already been prepared, and as a result a response packet experiences short delay in the network. A detailed evaluation targeting a 64-core CMP running scale-out workloads reveals that CMA improves system performance by 21% over the state-of-art hybrid circuit packet switched network. Let us see the flow of our project. In our project, first we have to send the 8-bit or 16-bit data to the destination via our neighbor nodes. From that we have to create mesh topology based CIMA, that is circuit and packet switched interconnection based mesh topology. In that we have to create the single router architecture design, that is 4x4 router architecture. Our information data packets sent via our neighbor nodes, so we have to identify the neighbor router estimation. After identifying this neighbor router, we have to calculate the weight, because is a single source node have multiple neighbor routers, so we have to identify which path is shortest. So we have to calculate the weight depending upon the VC allocation, arbitrary logic, and the crossbar. If the minimum distance is calculated, then that node is taken as the neighbor and send the information via that node to the final destination using our shortest path identification process. In our process we have to use master slave concept, that is our source node is act as a master and all other nodes are act as a slave nodes. And also we have used the switching process, that is after calculating this weight we have to switch which neighbor is suitable for sending the packet information. So switching process is also done in our project. Let us see the output of our project. For running our project, open our project file, that is in Xilinx software. So this is our coding file. In that we have to click this simulation radio button and click this simulate behavioral model. Now it will open one window, that is called iSIM window. In that window we have to set our input data bit and reset. First give the reset and we have to give the input bit, that is 8-bit input data. First we have to give the enable as 0. So now run the process. So now we have to reset as 1 0. It will start processing, that is the D in input is sent via this neighboring node. So P0 to P15 is act as a neighboring nodes. If we enable this ENW as 1, it will start the process. So now the process, that is now our input is travel along P0 wire, that is P0 is a neighbor. Now it going to the P5 neighbor. P5 check it process, so this is not, it is not a destination, so it sends to the P10 neighbor. So now also no output is displayed, so yet the process is not done. Now the P15 receives the output, so data out is 10101010. So for running our synthesis report, click on this implementation and click this run this synthesis XSD, that is double click on this. We have to produce this design summary. In this, click on this synthesis report. It shows our time, area, power consumption of our project, how many flip-flops we used, how many memory we used. So this is our synthesized report. Out of these numbers, we have to use a less amount of registers, logic gates and memories. In time management, our arrival time is 1.271 nanoseconds. For running our RTL diagram, click on this view RTL schematic, okay, and click this add create schematic. This is our output RTL diagram. So we have to create master memory and all the slave memories, and all the processes are inverted and it will produce the output. For technological schematic diagram, open. This is our technological schematic diagram. This is nothing but the lookup table number and the number of flip-flops in our process.